Hi, in this video we will learn basics of the graph of a function. So let me start with the what is the graph. So let f be a function well, from subset of R to R, real numbers, on real numbers. Meaning that the domain of the function and the range of the function are subsets of real numbers. Then the set of all points of the form. So you put all the points of the form that the first component can be any number in the domain. A is a number in the domain. But the second component or second coordinate would be the value of the function at that number. Whatever the first component is, evaluate the function at that point and then plug in into the second component. Set up all such function form such points form the graph of the function f. Function f. Well, so you start finding all the points, means that, okay, for all x's in the domain, for example, x equal to 1, you find value of the function at 1. And then you find function value of the function at 2. And then, and so on. So find all, if you find all these points that have those properties, they will form the graph of the function. As you can see, it's not easy work to do, but we will later in the course we will learn very good techniques to sketch such a graph. And in our case, we will be able to do sketching of easy functions. One thing as a remark is that note that if we take the first component to be x and second component to be y, so based on the standard convention, so the first component is x and the second component is y, the graph of the function, is basically when is obtained by setting the second component to be the value of the function at the first component. In other words, y to be equal to f of x. And this is why sometimes you see that we don't have any function written explicitly. People would say just y equal to some expression in x. Sketch that graph, and that's coming from this fact. Let's do some examples here. Example. Sketch the graph of the given function. What are the functions? First one is f of x equals to 2x plus 1. The second one is f of x equals to x squared plus 2x plus 3. Well, in both cases, we will start with the fact that, okay, we are trying to find all points whose y is equal to f of x. Okay, well, right away you see that this is an equation for a line. This is an equation for a line. And to sketch line, we already know we don't need to find all the points, we need only to find 2 points. So 2 points are needed. So 2 points are needed. Well, how do we find those points? Plug in different values of x equal to 0, it gives me y equals to 2 times 0 plus 1, and that gives us y is equal to 1. So 1 point is 0, 1. The second point, plug in any other value. You could have plug in y equal to 0, find x-intercept, but let me just do this one this way, and then y is equal to 3. So 1 and 3. 2 points on a line are known now. Now we can just plot these points. 0, 1 is here, and then 1 and 3, 1, 2, 3. So this is a 1 and 3. Since we know it is a straight line, now we can just place the line passing through these 2 points. That's the graph of the function f of x equals to 2x plus 1. For this other example, we just put y equals to x squared plus 2x plus 3. And you see that this is equation for a parabola, yes? Parabola. And to sketch graph of a parabola, well, I have prepared a review video. You can watch that first, but I will just go quickly in this case. Step 1, find the axis of symmetry is given always x equal to minus b over 2a. Well, parabola, remember, is of this form: ax squared plus bx plus c. In this case, a is 1, b is 2, c is 3. And the axis of symmetry here would be minus 2 over 2 times 1, which is negative 1. That is axis of symmetry. Then step 2, find the vertex. Find the vertex of the parabola. So what is the vertex? Parabola, vertex is the point at which the increasing decreasing property of the parabola changes. How do you find it? Well, put this, for the x value, you put the axis of symmetry minus b over 2a, and for the second component you plug in that number into equation and then find y. So in our case we have negative 1, and y plug in x equal to negative 1 would be negative 1 squared plus 2 times negative 1 plus 3. And that gives us negative 1. And 4 minus 2 is just 2. So that is a vertex of the parabola. Step 3 is that, well, you find few more points, but specifically, well, in different books you will see different things, but find few more points, just to give you a good idea how to place your parabola there. Usually what we do is that whatever the minus b over 2a is, you add plus 1 to that, negative b 2a plus 1, and you take negative b 2a minus 1. In some literature, you will see that there is another plus 2 minus 2 also. So plug in for x those ones and find values of y, and those will give you the points you like, you need. So in this case, the x for me is, well, already negative 1 is 2. For negative 1 plus 1 would be 0. That will give me 3. Negative 1 minus 1 will give me negative 2, and you plug in, you get again 3. So 2 more points are now negative 2, 3, and 0, 3. Well, this gives you basically everything you like, but there's a hint, or there's a point you can keep in mind, that if a is positive, the parabola will look upward. So like this. If a is negative, on the other hand, the parabola will look downward. So in this case, a is 1, so this is the hint you can always use to make sure that you are on the right track. So our parabola is going to be like that form. Okay, so we find the points here. 0, negative 1, 2, this is the vertex. 0, 3, and negative 2, 3. And remember that this is vertex, the axis of symmetry. It means that it will act like the mirror for our parabola. So the parabola needs to be symmetric with respect to that, almost. And that is the parabola, and hence the graph of the function f of x equal to x squared plus 2x plus 3. Well, now that you see the graph of a function is a curve, you may ask yourself, is every graph a graph of a function? So every curve or every graph, so let me curve. Is every curve a graph of a function? Well, one thing that you have to recall, that function for each x, there exists a unique y. It means, in terms of the graph, it means that for any number you put here, there will be only one point with that a to be its first coordinate. Only one point on the graph of function with first coordinate a for all a's. Well, if you translate this in geometric ways, this will give you what is called vertical line test. Vertical line test, which says a curve is the graph of a function if every vertical line intersect the graph, the curve at most once. There might be points that at which the graph doesn't intersect the vertical line, but if it intersects at, it cannot be more than 1 point. As an example, for example, if we have a graph like, let me draw some graphs, we check these ones. Okay, if I have a graph like this one, or if I have a graph like this, or if I have a graph like this one here, let's see which one is graph of a function. Vertical line test, it says that sketch, well, draw any vertical line at most once the vertical line can intersect the curve. If that's the case, that's a graph of a function. Here for this one, we have this. So far so good, but then at this stage you suddenly get 3 intersection points, or here you get 2 intersection points. This means that it fails vertical line test and it's not graph of a function. How about this one? Well, we draw this vertical lines. Everything is good. There's only one issue here. You see this vertical line, when you see solid bullet points, it means that it is included in the graph. Here, this vertical line, this specific one, intersects this graph in this point and this point down there, so that fails. Only one such vertical line is enough to say that the graph is not graph of a function. Okay, so in this video we learned basically what is the graph of a function, how you sketch if you know the right curve, and then the test called vertical line test says when a curve is a graph of a function.